Okay, so today in class we spent some time talking about on pages 1 and 2 the ways solutions are formed and some of the ways to change the rate of dissolution, how fast something dissolves. We may have then skipped this so that make room for the video tonight. So we may have actually started talking about ways to change how much can dissolve. And so we've kind of given away a little bit of what's going on here on page 3, which is the definition of solubility. That would be is essentially the ability to dissolve, but it's a little bit more than that, and we're going to talk about how we might change that solubility definition just a bit. So solubility is a measure of how much solute can dissolve in a given amount of solvent. Now there are lots of ways to define this. You can do this slightly. I'll put this in old font so you can see that that's the added piece, but you can actually do this a bunch of different ways. You can talk about it being when the maximum amount of solute is dissolved in the solvent, the ability to dissolve. There are lots of ways to do this, but I want to try and keep it a little bit quantifiable by saying it's a measure of how much solute can dissolve in a given amount of solvent. Because obviously, if you have more solvent around, then you probably can dissolve more. Just think about having water and salt. You have more water, you can dissolve more salt. But let's tie this into the whole meaning of saturation. So you can even go back to page 1 and recopy what we wrote down yesterday for what the definition of saturated is, which is when the maximum amount of solute is dissolved. So if that's the case, put these two things together. How could you put solubility in terms of the word saturated? So I'd like you to try and write a one sentence, and you can do it in pencil if you're that worried about having to erase it, but I want you to write a one sentence definition of solubility in terms of the word saturated. So the word saturated should appear in your definition. That's going to change the first sentence, but only a little bit. But I want you to try and define it in terms of saturation. And for that, I want to take and after that, I should say, I want to take a look at reference table G, because that is the reference table that's going to have information about solubility of a variety of solutes. So if you take a look, forget the problem that's on the notes, but I'll just back out of here for a second. Actually, what I'll do is I'll snap this to the side so I have both going at the same time. Scroll down to table G, and I'll maximize this for a second, because the first thing you could say to yourself is, oh my goodness, what is going on here? That is a big mess of lines. And it's true, and you can tell the lines aren't very well behaved. They don't look like standard like math graphs or anything like that. Some of them have a kind of a shape like that, but they're not very well defined. But the good news is that you're going to be asked specifically about different solutes. So let's just take a look at the axes for a second, then we'll start doing some problems with it. So on the x-axis, you've got temperature. And certainly, as you might imagine, temperature affects how much you can dissolve. I know we talked a little bit about this yesterday with the rate of dissolution, but if you think back to the iced tea example, you might think about the fact that in hot tea versus iced tea, you will be able to dissolve more sugar, not just dissolve it more quickly, but actually dissolve more sugar in hot tea versus iced tea. And then on the y-axis, you'll notice it says solubility. Just turn your head 90 degrees, you'll read it just fine. Grams of solute per 100 grams of water. Now it has to say this per some amount of, in this case, water, the solvent, because if they don't specify that, well then you could dissolve anything just depending on how much water you have. So they do that just to make sure that everybody's talking about the same thing. So solubility here is measured in grams of solute, and the solute is just whichever one is listed in the particular curve, per 100 grams of water. So what I want you to do is go back to the notes now. I'll snap this back because now we can look at it a little bit more reasonably here. Okay, zoom it out a bit. Okay. There we go. So if we dissolve 10 grams of sodium chloride in 100 grams of water, have we saturated the solution? Let me just reduce this back to 100%. Now we can fit this on. Can we have we saturated the solution? Well, let's take a look. Where would that be to have 10 grams, 100 grams of water? So it's per 100 grams of water. So that's this 10 grams is right here, anywhere along this line, and here's the line for sodium chloride. So what this graph says that you will be able to dissolve about 38 to like 39, maybe a higher temperature, maybe 40 grams of sodium chloride in 100 grams of water. And we're putting 10 in. So have we saturated it? No, we haven't saturated, not at any temperature. So sometimes it depends on the temperature. So you see some of the curves are rather steep, like the potassium nitrate one's very steep. That's not true for sodium chloride. So no matter what the temperature is, we will not saturate. What is this type of solution called? Yeah, it's really creative. It's called unsaturated. Okay, there's no reason to make it any more difficult than that. So an unsaturated solution. Now, here's a good question about another way this can be asked. Is at 25 degrees Celsius, what is the solubility of NaCl in water? So for that, you got to actually start looking. 25 here. Now, what would you call that? You're just looking at where it intersects. So you'd call that, all right, so let's zoom in a little bit, see if we can do a good job on that. Because the Regents giving you a full page reference table is going to expect that you understand something here and that you can read it to a pretty good degree of accuracy. So I'd call that about 38. What kind of leeway they're going to give you on a question like that? Plus or minus 1. I mean, 39 is really a hard sell here. 37 is probably a better sell, but 36 would not be a good, it's hard to prove 36 on that kind of position. So 38 is going to be kind of it. And they'll give you a little bit of leeway, plus or minus 1. So how do we write that? The solubility is 37, I'll go back to bulk here, 37 grams of NaCl per 100 grams of water. And yes, you do have to get a little bit, specific about it because, again, we have to say how much water we're talking about. So here's the follow-up question. How much salt would I have to dissolve in 100 grams of water at 25 Celsius to create a saturated saltwater solution? Now that's for you to put in there. I'm going to check that tomorrow as part of your homework, but that should fall right out of your definition from way up here that you did in terms of saturation. Not looking to, go nuts here, just answer the question and then it'll be fine. Now, you have a couple more exercises to do. I want you to find the solubility of these salts per 100 grams of water at all the given temperatures. Now, I'm telling you it's per 100 grams of water, so you can just write the mass down. So KNO3 at 50, that's potassium nitrate, ammonium chloride at 20 Celsius, and then sodium nitrate at 70. So you can use table G to take a look at that. All right, so there you go. That's the beginnings of looking at table G.